Even
Yes.
yes. Okay. All right. Okay. So so the title or the task given to me by the committee was to how to be a clinical researcher and the available resources. And let me see. Okay. So the disclosures are, of course, I'm a US federal government employee and I don't make a whole lot of money because of that. So I don't have any financial conflicts of interest. And these views are my personal views, and they are not any way endorsement or official statements from the National Institutes of Health here in Bethesda, Maryland. Uh, before we go there, I just want to kind of put the framework in terms of what are the objectives of this talk. Some of the things I've already talked about, but just to kind of establish a framework. So most important question is that why do we even want to do research? And of course, there is no one answer to this question, and all of you will have a different answer or maybe a combination of answers. So I do want you to start sort of thinking that why you're here, why do you want to do research, what is it that the clinical research means to you. In the second part, I'm gonna walk you through these 8 steps of clinical research. And again, this is not like the 7 habits of highly successful people or something like that. It's just what I thought about it. And of course, you can agree or disagree or add to this, but this is just my personal sort of roadmap to clinical research. And then I try to provide some of the resources. Of course, there are hundreds of resources available. Anyone can do Google search and find these resources. But I just put out some pertinent resources, and like I said, there are plenty of others. And then at the end, I would present few of the ideas for our clinical research, as I said. But before we do all of this, I do want to share a little video with all of you. And this is a video about the Discovery Channel coming to the NIH where I work, and they did a 3-part of this the video. Some of you may have watched it and some of you not. So I'm just showing you the trailer of this video, which is about like a 1 minute that I would like to share with you. And this is basically Jim Parson, who some of you will know from the TV show and know him as Sheldon. And he was here, and then the whole team was here, and then they did a remarkable job in terms of doing this. So it was called First in Human. And let me see if I can share this video with you all. Okay, is that the one? No. Here it is. So can you all see it now?
Yes.
I'm in a laboratory that's part of the largest hospital in the world dedicated solely to research, the National Institutes of Health's Building 10. Imagine you're diagnosed with a life-altering condition, like cancer or diabetes or heart disease. Your doctor recommends a standard course of treatment, and you breathe a sigh of relief knowing medicine has something to offer. You are comforted knowing that so many others have already benefited from it. But where did that pill or therapy come from? For every treatment we rely on today, there was a moment when no one knew if it would work, and a first brave patient volunteered to try it. What's called a first-in-human trial. Now, for the very first time, the NIH has allowed cameras to follow these patients and doctors on their remarkable journey. I'm Jim Parsons, and this is First in Human.
Okay, so I'm sure you are able to appreciate why we do clinical research, and that was one of the reasons to show this, to sort of build this momentum in terms of why it is important. And of course, it all comes down to helping patients and making their lives better. So So the question I wanted to pose to the audience, and again, this is not mutually exclusive answers, but why are you or I am interested in doing clinical research? And there are a number of answers that we can give depending on where you are in terms of your career or what is your driving force. So either it is due to intellectual curiosity, or it is part of your career advancement, financial gains, even though you don't make a whole lot of money doing clinical research, and it's a labor of love, and except that if you are in a big pharmaceutical and you're doing a large phase 3 trial, sometimes you do make money, but that doesn't happen quite often. And discover new and better therapies. That's sort of the goal, that we like to make sure that our patients are treated better. Developing research infrastructure in Pakistan. I think that is the goal from the Apna Merit Committee, and they're doing a tremendous and remarkable job with that. The clinical practice based on data generated by local population. And this is the point that drives me, because when you look at the clinical studies, when you look at their clinical trials coming out in New England Journal or other reputable journals, the most of the population is either Caucasian or sometimes even some of the North American and European, and sometimes there is a mix of some Hispanic and some Asian. But we do genuinely lack the data from the Indian subcontinent, from Pakistan. And even though we use the data generated by doing research on populations which are very much different than us, but then we are using the same data to make our clinical decisions. So I think there is a lack of data generated by our own population doing clinical research to find out what are the genetic factors, how do our patients respond to certain medications, and how do they don't respond. Is the same dose of a blood pressure medication, which is effective in a patient who's Caucasian, will be the same dose of medication or same medication that can be used in a patient who is, for example, from Hyderabad, Sindh, or from Rawalpindi, Punjab, or so forth. So as you know, I'm sure most of you appreciate that there is a difference in how different populations do respond to different medications or treatments, and of course there is a social construct to it, and there are so many other factors that we don't even embark upon. But at least there is a lack of data that we do need to generate that data from our local population. And there could be other reasons, and if you have a specific reason that I have not listed here, please feel free to put that in the chat box, and of course I'll be happy to discuss more at the end of the talk. Now with that, let's just talk about some more tangible, some more substantial things in terms of what are the 8 steps of clinical research. Again, these are just what I thought about it and kind of write it down. So this is somebody who just want to start clinical research, if they're early in their career, a medical student or an early intern or resident. So I just put it down here as the first thing is that everything starts with an idea. And then we'll talk about all these things a little bit more in detail. The second part is the literature review or the background to sort of see if your idea is even novel. Then having a question or a hypothesis. Then after that, you develop a study protocol, because clinical research is all about thinking about things systematically in an organized manner, and then following them in an organized manner based on a study protocol. So it's not something that you or I thought about in the middle of the study that, oh, this is how I should do it. No, we have to follow the protocol. That is like the number one thing that if you're coming from a large clinical background going to a research background, you have to sort of make that mental switch, that how do you follow something that is written, even though it may or may not make a whole lot of sense, but you have to follow the protocol. Then the other thing is about the resources, and we talk a lot about funding, but I do want to discuss a little bit about the human resources. And then the next step is the regulatory approval. And I'm very happy to see that a lot of progress has been made in Pakistan in that aspect. We just recently established a collaboration between NIH and one of the institutes in Lahore, Punjab, and I was very pleased to see that how they are following the international standards of regulatory approval. Then implementation, of course, that is the next step once everything is approved. And then finally, when you're done, you do analyze the result, and most importantly, you would like to publish. But I do want to emphasize one point, which is again coming to the literature review and background, that this, especially when I review a lot of grants, or when I see the students coming to me, this is the part that is often overlooked or neglected. But in my mind, and I'm sure a lot of colleagues who are involved in research will agree that this is in fact one of the most important part. That's sort of before you go on to anything else, this is the thing that you need to spend most of the time to understand what is the knowledge gap, and what is it that your idea that you're presenting, how is that idea going to fulfill that knowledge gap. So this is something I cannot emphasize enough. So now looking at these steps in a step-by-step manner. So the first step is the idea. So the question is that where do the ideas come from? And of course, when you're in clinical practice, you're looking at the patients and you see something intriguing and you said, okay, this is a knowledge gap that I don't know how to do this better, or is there a better way of treating this patient? And of course, that's where you come. And then reading the journals, reading the different um, uh, research that has been published, then you say, okay, there is something that they have identified, but they are not able to completely answer this question. So maybe there is a knowledge gap. This is where the idea come from, and all of these coming together. And the third thing is that discussing with your colleagues, going to the conferences, having an interactive and curious mind. And this is how the ideas come to your mind, and then you come up with an idea to answer a specific question. So nothing too fancy about it. Now the literature review or background, coming to the point that I was trying to emphasize again. So there are a number of resources that are available. If I look outside my window right now, I can see the building of the National Library of Medicine, and the National Library of Medicine is where the PubMed is housed, and PubMed is one of the biggest resources for the for doing clinical research. And even though it is housed right here in the campus where I am sitting right now, but the resources are freely available for rest of the world. And any of you, since I have access to pretty much every article, every journal, due to my job, if any of you would need some article, or are doing literature review or research and they're stuck, please shoot me an email, contact me. I'll be more than happy to send you those, download the articles and send it to you, if let's say you don't have access to a particular article that you would like to read. But in addition to PubMed being the biggest source and freely available source for research, there are other things such as the Web of Science, the Elsevier have this Scopus, there are EUNet, and multiple other resources. But one thing I was pleasantly surprised is Google, actually. Even though we sort of tongue-in-cheek say that, okay, go and search it on Google, but to be very honest, I found Google to be a very good resource for doing literature review and background. And a lot of time when you put the search, the power of Google search engine is so much that it actually provides you better results, or returns better results as compared to PubMed. So so sometimes when I get stuck and I'm not getting the search results that I'm looking for, if I go to Google and then I use those results to search something, go back in PubMed. So not something to be undervalued. You know, and of course there are many other resources, but these are what I thought would be one of the few of the important resources, and most of them are free. Okay, so now we have the idea, we did the literature review, we see what is the knowledge gap that we would like to fulfill with our research. What is the third thing? So the third thing is stating the question and hypothesis. And you know, the research idea, again, it's all about being organized, about thinking systematically, about having yourself a structure. So the idea has to be structured into a well-built question or a hypothesis. One of the ways to sort of organize your thought is to think about this PICO components. So the PICO, what does it stand for? So it stands for the population of interest. So what is the population of interest that you would like to study? That is the number one question that you answer. Then the intervention that you would like to be tested, whether the intervention is a medication, intervention could be an exercise, intervention could be even a behavioral intervention, or some type of educational intervention. Intervention does not always mean a drug. So it could be anything. And then the third part is the comparison strategy. So you want to test your intervention in one, and then you want to have a same population where you don't have the intervention, and then you compare so that you see whether your intervention have some results based on this comparative strategy. And then of course the last thing is the outcome. So what is the outcome that you're trying to find? What are the outcome that you're looking for, and how do you define those outcomes? So framing your question in this manner helps. And again, this is not the only way to do it. This is just one way of doing this, which I thought may be pertinent to give you some tangible ideas. Now, going to the fourth step is the writing the study protocol. And a study protocol is probably not something which is the strongest forte of any of us. And I also struggled with this initially when I started on it. And eventually it took me a while. But fortunately, there are a number of resources available to write a study protocol. So at the NIH, the IRB has actually publicly established this website, which is the my first bullet point here, which is the irbo.nih.gov. And if you go to that website, they have freely available all these resources where you can have various templates. So for example, if you're doing an interventional study, there is a template for that. If you're doing a natural history type study, if you're doing just some biospecimen, if you're doing some behavioral study. So all of those templates are there, and you can use them as a guide to write your study protocol. Of course, things have to be in a local perspective. So some of the things that are applicable only for the US may not be applicable for Pakistan or UK or other places. And those are small parts, the regulatory parts of the protocol. The most of the bulk of the protocol is pretty much similar. I review grants from a lot of European countries. For example, I reviewed grant recently from Finland and also UK. And I was very surprised to see that their their study protocol structure was pretty similar to what the one used in US. Some of the other tools I have listed here are the e-writing tool, which again helps you write a protocol. So you can just go to this website and then you can start. It will help you write the protocol electronically. Then I also find a resource from NHS in UK, and they also have some of the resources available where these templates and so forth. And of course, there are several others that I did not list, but you can of course search and find out. Now going to the fifth step, which I think a lot of us get stuck on and feel that we don't have the resources to do research. But I do want to kind of challenge that notion, and I would like to propose to you that we do indeed have a lot of resources, and we have a very large pool of resources. And the reason I'm saying is that the research is not always just the funding. And what do I mean by that? So what I mean is that the number one resource that we need to do research is human resources. And I think in Pakistan, alhamdulillah, we have such a rich resource of human resource. We have no breadth of talent. We have extremely talented people. It's just that we just don't have the proper infrastructure to nurture that talent. And I think again, coming back to praising Apna for starting this series so that they can develop some of that infrastructure and make people aware of the resources available to do research. So so if, let's say, for example, you are somebody who just started want to start clinical research, so how do you develop your research skills? How do you develop that human potential? How do you develop the skills from being a clinician or from a medical student or an intern? How do you go on that journey? And I have taken that journey myself, so I can vouch for that it's not an easy journey. Again, it's a labor of love. It takes time, but at the same time, if I can do it, I'm sure any of you can do it. So it's not impossible, it's difficult, but there are resources available, and please use these resources. And if you need any more resources, please feel free to contact me. I'll be more than happy to guide you, to provide you more resources. So one of the things, one of the books which I would recommend all of you must read before you start clinical research is this book. is by Steve Hulley and colleagues, and it's called Designing Clinical Research. And it's sort of like a very stepwise approach. It starts from a point zero and take you all the way to the end. And if you read this book, and also you can use this as a reference. Another book which I would recommend to all of you to read is The Principle and Practice for Clinical Research. And it's written actually by John Gallen, who's the head of the clinical research at the NIH. And there are multiple people here who are part of the NIH and also around the world who contributed to this. It does cover a vast number of topics, and it gives practical advice to both novice and advanced clinical investigators. And it is as sort of an essential resource for you. And it also gives a lot of hands-on practical suggestions, illustrations, examples, and so forth. So these two books I would highly recommend all of you to please get hold of them. Okay. Now, second part is some of the courses. The NIH has a lot of free resources in terms of courses that you can go and do, and now everything is available online. So one of this course, which is the Principles and Practice of Clinical Research, is an excellent resource. And this is a course that is developed by the NIH, and it is taught in more than 140 countries, more than 140 universities around the world. It used to be a very only a on demand, only a resource where you can only log on at a certain time. And now what they have done is that it's an on-demand format. So you, as long as you go and register, and again, it's all free. All you need is a Gmail account that you can go and register, and then you can either register as an institute or as an individual, and you go through all these resources, about like 40 lectures, and then which from the world-class experts actually. And once you complete it, there is an exam that you need to take, and if you do 75% or better in scoring on that exam, then you get a certificate of completion. And this is a certificate which is highly valuable as a clinical researcher, and kind of establishes that you are indeed, you have taken the time to learn about clinical research. And then the other, this is more like a training modules where it just sort of trains you in terms of various aspects of clinical research, in terms of what are the regulatory aspect, what are the ethical concerns. And so some of it is overlapping with the course, but the modules, again, the modules are needed, at least in the US, these modules are needed for and for you to be established as a clinical research. So anyone who does clinical research in United States, and I'm sure in other places in the world, they have to do these modules and pass these modules, which gives them a certificate. And once you go to the regulatory authority, they say, okay, you are coming to us saying that you want to do research. Tell us that you have the skills, or you have learned enough to do the clinical research. And that's how you get established doing this, by doing these modules. Again, it's free. I've given the link here. You can go onto that link and register yourself and do these modules. It takes about like 6 hours to complete all 4 of them. And there is a quiz, and if you score 80% and above, then you get the certificate of completion. Again, it is free. So all of these resources are freely available. They're highly valuable resources. Okay, so now we have the idea. We did the background search, wrote the protocol, and we have all the knowledge and skills in terms of human resources. So what is the other part that you need? So you need to have, in addition to you yourself or your team having the skills, you also need certain infrastructure. So you need people who are research coordinators who can help make sure that the protocol is being followed, and you're and a lot of times these are institute-based things that are needed. And I believe that having a data manager is also very important for somebody to kind of collect the data and enter the data. Having a biostatistician is also important. And again, if you know, for example, the one way the NIH and other institutes do these things is that they develop a core. So they have a data manager core, they have a biostatistician core, and you are a research coordinator core, and so that you can pool your resources. So for example, there are 10 people doing clinical research, and there are 2 research coordinators, so they can dedicate their time to these 10 different people if they're not too busy. And same example is a data manager who can support 10 different researchers, or a biostatistician who can support multiple researchers. So this is not something that you need a research coordinator for each and every study and so forth. Then you need to have a research database. And again, the REDCap, I'm sure a lot of you already know about REDCap. But REDCap is an open source, freely available research database. And anyone from anywhere in the world can register with REDCap, and they can use their infrastructure for building their own research database. And there is another one, which is the nnlm.gov. There is also data tools there that you can use. So these are again freely available, but these are the infrastructure things that you need. And then of course you need the physical space, you need computer software, you need labs. If you're doing bench research, which I think we are not talking, we're most talking about clinical research, but at least you need to have some physical space, you need to have software, which I'm sure pretty much all of you would have. But I do want to emphasize the two things that I've circled on the left. Then the third part of having resources is the funding, which I think a lot of us kind of wonder. But I think even though we get kind of bogged down with funding, but for a lot of things that I may tell you a little bit later, you may not need a whole lot of funding. So national resources, as Danish initially said, is the HEC is the biggest funding resource in Pakistan, and I'm sure all of you already know this. The Pakistan Health Research Council, then the Pakistan Science Foundation, they also give grants for clinical research. And interestingly, the British Council in Pakistan also gives grants for clinical research. And I believe a few lectures back, there's somebody who did present a lot of resources that are available, but I just listed a few of them. The international resources, the Fogarty Center in the NIH is one of the biggest resource for international research. Some of the institutes in Pakistan, especially FAAN and some other institutes, have been funded heavily through the Fogarty International Center. They have successfully competed for grants. Then there are industry-based. Of course, the investigator-initiated research is one way to do this, and I have successfully received funding based on investigator-initiated research. And then also there is this joining a multi-site clinical trial. And the reason I put this in red is that I think this is probably the most tempting or easiest way of doing clinical research. But I do want to, I shouldn't say that I want you to steer you away from this, but I want you to say that, don't think that you have to do clinical research just joining a multi-site clinical trial. There are so many other things that you can do. Again, it's a labor of love. You need to put in some time and effort. But if you can resist the temptation of starting out by joining a multi-site clinical trial, I think in the long run, you will be much more, you have much more skills. And then then actually you don't look out for the pharmaceutical, they keep on reaching you. I mean, for example, I almost on a weekly basis get approached by multiple companies because they want me to be involved in the research. Of course, that's not what I want to do, but at the same time, once your portfolio goes out there, then they are always looking for people like who can do clinical research. And then there are multiple foundations. I mean, the most familiar to most of you is the Bill and Melinda Gates, but of course there are multiple other foundations that give out research. Then the disease-specific organization, for example, the American Heart, the Alzheimer's Association, and so forth. All right. So, so those are the resources that are available. And of course, like I said, they're all available. You can do Google search and then you can find all of these resources, but this is something that's for a reference. Then the step 6 is the clinical research, or is the study approval. So the regulatory approval, again, I was pleasantly surprised that Pakistan has done so much progress in that aspect. It's important that it's not only important, essential that anytime you're embarking on human subject research, it needs to be approved. It is required before starting research study, and any type of research you're doing, either it's a retrospective, prospective, observational, or interventional, you need it to be approved. And why it needs to be approved? Because there are ethical issues. You want to make sure that there is a do no harm or freedom from harm. There is a right to withdraw, that anonymity, confidentiality, informed consent. These are the key ethical issues. And of course, this is outside of the scope of this talk to talk about these. But I do want to sort of bring this point that when we are doing research, not only it's important that we follow the protocol, we want to make sure that we follow the highest ethical issues, because if somebody is volunteering to be a research subject, we want to make sure that we do protect them and follow these ethical concerns. And then the seventh step is the implementation. Once you have everything developed, you have to develop the data collection form, the database, the spreadsheet, REDCap being one of those. And then you need to follow the written procedures as outlined in your protocol, and make sure that the data is accurate and complete. Because when you're doing research, you have to be very obsessive compulsive. You need to make sure that you have procedures in place for checks and balances, and there has to be almost zero tolerance for any kind of error, because it's a very high bar and very high standard. Of course, as professionals, we always follow very high bar. We have a very high bar, and we all hold ourselves accountable to a much more higher standards, because we're dealing with human life. But in clinical research, there's an added element to that. And then you want to make sure that you are on an ongoing basis, make sure that your protocol has been adhered. There are organizations who do that for you. I'm not sure how much of that is available in Pakistan, but in US, there are organizations who just make sure that you are adhering to the protocol, and they give sort of an audit report based on their review of your site. Okay, the last step is to present and publish your results. So, just sort of put this as a joke, but I think that some of you who are involved in clinical research know this very well, that publish or perish. So you want to make sure that whatever you have done, you are publishing it, and when you're coming from your idea, going to your research, going to analyze the result, then write and make sure that you publish. So all this will perish. All these steps will perish if you don't publish. And once you publish, then you repeat and you do this, and this is a cycle that you keeps going on and on and on. And of course, it has multiple benefits. Again, not an easy task, but make sure that that whatever results you have, you publish them. Okay. So again, these are the 8 steps. I just put them out there just as a refresher. So starting with idea, literature review, and writing a question in a scientific method, and then writing the protocol, then human resources and funding, regulatory approval, implementation, analyzing result, and publishing. Okay. So in the next few minutes, I just very quickly want to go through some of the ideas about clinical research. So we talked about the 8 steps. We talked about how we can establish ourselves with clinical research, what are some of the resources that are available, and we sort of begin with the framework where we wanted to see why even we want to do this. So after doing that, I thought that it would be maybe a good idea to leave you guys with some of the ideas and some of the sort of the low-hanging fruit, where you don't need to have a whole lot of resources and effort, but it's still at least start some kind of a clinical research process. So what are some of those ideas? So one thing which has helped me a lot in my career, and a lot of people that I know, their career got established as a clinical researcher by establishing a disease registry. And I think that is something that we do lack in Pakistan. My push with some of my colleagues in Lahore that I've been working on is to establish a lupus registry, or maybe an autoimmune disease registry, because that's what I do research in. But even for other diseases, I'm not sure if there are disease registries, for example, for diabetes, for high blood pressure, for hepatitis C, for the diseases which are so much prevalent in Pakistan. But establishing a disease registry is very helpful, because it does you do collect data in a uniform fashion related to patients with a specific diagnosis. You develop some standard clinical data collection form, and you can track their clinical care and outcome for chronic disease. And it doesn't take a whole lot of effort. So it's basically a low cost, high impact research. It doesn't have to be a very fancy, big. If you have access to, for example, Microsoft Excel or Microsoft Access, you can easily establish a registry. Again, REDCap is freely available. You can go to RedCap and it will help you establish a disease registry. And if you are able to dedicate some time to establishing a registry of whatever disease that you are interested in, whatever the disease that you are expert in, it will help a lot. It will generate a whole lot of data. It can open up so many avenues for you in clinical research. For example, you can study mechanism of disease by doing something like a case control or a cross-sectional study. And in interest of time, I'm just going to go through these real quick. But of course, I'm available and I'm happy to talk about these things more in detail. For example, establishing a case control study, it's not that hard. You define your study population here, and then you divide them in the ones who don't have the disease, those are your control, and then those who have the disease are your cases. And then you look at certain exposure, for example, blood transfusion. So you see if the cases, how many of those people who have blood transfusion have hepatitis C. So how many of them were transfused with blood, were exposed or non-exposed. Again, you look at the cases exposed and non-exposed, and then you conclude that blood transfusion is extremely safe in Pakistan, and the blood transfusion is not a source of hepatitis C in Pakistan, for example. So then again, mechanism of disease, the other way to do is a cross-sectional study. Then you're only looking at identify subjects from your population, and then again look at the risk factors and if their disease is present, if there is a risk factor but no disease is present. And then again, you have two more boxes where you say that risk factor but no disease, but then no risk factor and no disease. So you have these four parts of the population, and you can do a cross-sectional study. And again, it doesn't take a whole lot to do this. You can do a prognosis study. Again, just coming back to the point that I started out, that all of this is built upon establishing a registry. Then prognostic study, so you can follow the patients for a long time. For example, the registry that I have is a lupus study, which has been established more than 26 years ago. And we recently had a 25-year celebration where we are able to follow the patients for so long. So now we know patients who are like 17, 18 years old when they have lupus, and now they're like in their midlife, 45, 50, and now what has happened to them, what are the different exposures, what was the outcome, how many lived, how many died, how many were hospitalized, how many had renal failure, things like that. So prognostic studies can be long-term. If you are at the institute for conceivably for a long time, then you can do these type of studies. Again, this is just a pictorial way of showing that. Descriptive prevalent study, you can do maybe just a survey to find out, for example, a certain neighborhood in Karachi, what is the prevalence of diabetes, and is it different than another comparative, and whether there are socioeconomic factors that are causing more high blood pressure, diabetes, in, for example, Nazimabad, Karachi as compared to Clifton, Karachi, or vice versa. So these are the things that you can do more of a descriptive prevalence study. Again, doesn't take a whole lot of effort, but just need a little bit of organized thought and organized way of working on these things. Systematic review, meta-analysis, not typically you think about clinical research, but there are resources available how to do systematic review. And if you have biostatistician available, they can tell you how to do the meta-analysis or help you with that. You come up with a question and then you do the research, and there are a number of resources available. You provide a statistical analysis summary. For example, the Cochrane database of systematic reviews there, it actually teaches you how to do systematic review, and those are easy. You can just do it on your time. You don't even need to go anywhere or interact with anyone. You can do a systematic review if you have some medical students working with you, and then you can all come up together. If you have biostatistician, you can do meta-analysis and so forth. Case reports, I think a lot of you are familiar with that. If you see something unusual, which I think in clinical practice in Pakistan, there is no shortage of unique cases because of our genetic admixture, because of the consanguineous nature of our population, because of the specific environmental factors, and there's not a whole lot of data coming. I mean, there is data coming out, but we can certainly add to world literature by putting Pakistan's name on the face of clinical research by putting out these case reports. So case reports, in the research community sometimes is looked down at, but in my view, I think case reports are very valuable and they do provide an important insight into rare occurrences of common diseases. So with that, I think this is probably my last slide. Again, I would like